3, which is 15 degrees. So really I'm looking for quadrant 3, so my cosine value is going to be negative, so I'm looking for the cosine of 15 degrees. Now remember that if it's not a quadrantal, if it's not on an axis, then our exact values are going to go back to 30, 45, and 60 degrees. Well, I don't know how to define the cosine of 15 degrees without my calculator, but I have this addition and subtraction formulas now that are going to enable me to find the exact value by using those. So if I'm looking at this, I'm going to rewrite 15 degrees with values I know. So let's just do 45 minus 30 degrees, which is the same thing as 15 degrees. I'm just rewriting that. Now notice that 45 degrees, I know how to find the exact values for all my trig functions for that. I know how to find all my exact values for the trig functions for 30 degrees. So now it's just a matter of using my formula in order to find the exact values. My cosine, my addition formula for cosine equals the cosine of x times the cosine of y minus my sign changes, the sine of x, the sine of y. Alright, and these are just my two angles. So in this case, 45 degrees is my x value and 30 degrees is my y value. So really I'm looking at the opposite or the negative of cosine of 45 degrees times the cosine of 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. Alright, up here I gave you the addition formula. We're actually using the subtraction formula, and that is the same thing except my sign changes. For cosine. Alright, so that's where I'm getting this from. And now I'm just plugging in my values. I know the cosine of 45 degrees is the square root of 2 over 2. I know the cosine of 30 degrees is the square root of 3 over 2. I know that the sine of 45 degrees is the square root of 2 over 2, and I know the sine of 30 degrees is 1/2. Alright, so just cleaning this up and multiplying straight across, I get the square root of 6 over 4 plus the square root of 2 over 4, and all that is negative because, like I said, we're pulling this out of the third quadrant, and my cosine is negative in the third quadrant, so this is just going to be negative square root of 6 plus the square root of 2 over 4. Okay? Alright, so let's do another one here. Let's do the sine, this is number 12, the sine of negative 5 pi over 12. You can do this however you want to. I'm going to convert it to degrees. So this is going to be the sine of negative 75 degrees. Alright, and I'm going to use the fact that I know that the sine is an odd function. So that just means I'm looking for a negative sine of 75 degrees. If this had been the cosine function, remember that cosine is an even function, so that negative would actually go away. Alright, so same thing here. I'm going to break this down. I don't know what the the sine of 75 degrees is, but I can rewrite this using the angles that I know. So this is going to be the sine of 45 degrees plus 30 degrees. And let me just make a note here. Let's go back up to this one, for example. I used 45 minus 30 to get 15, but I could have also used 60 minus 45. Because I know 60 and I know 45, and it's not going to matter. You're going to get the same answer. Okay, so going back to the problem what we're working now. So 75, I'm going to get that by 45, adding 45 degrees plus 30 degrees. Alright, so this is going to be my addition formula for the sine of x plus y. And that is just the sine of x, cosine of y, and then you swap it. So my sine stays the same, and then I'm going to do the sine of y times the cosine of x. Or I could have done the cosine of x times the sine of y. The order and multiplication doesn't matter. Alright, so let's just plug this in. So I've got negative, and then I'm doing the sine 45 degrees times the cosine of 30 degrees plus the sine of 30 degrees times the cosine of 45 degrees. All right, and then it's just a matter of plugging in the values that I know. So this is the square root of 2 over 2. This is the square root of 3 over 2. This is 1/2. This is the square root of 2 over 2. You notice that I'm getting the exact same answers, and a lot of these answers look just alike, so don't freak out about that. Think you're doing something wrong, because they are all going to look similar to this. Are they going to be positive or negative, or you're going to be adding or subtracting? So, all right, so there's that one. All right, let's do a couple more. So look at this. This is number 52, so it looks a little different. I've got a composition of functions. If you'll remember that when you see this notation, you should be thinking the inverse function. We had to limit our domain to find an inverse function, but this is asking for the sine of what angle is the square root of 3 over 2. Well, the sine of 60 degrees, or pi over 3, is the square root of 3 over 2, and this is asking for the cotangent of what angle is the square root of 3. Well, that's 30 degrees, or pi over 6. So really this is asking me for the cosine of 60 degrees plus 30 degrees. Now, you could certainly use your addition formula for cosine here and break this down and look at cosine of 60 times the cosine of 30 minus the sine of 60 times the sine of 30. I'm not going to do that here because I think you can recognize that the cosine of 90 degrees is 0. Maybe I will actually write it out so you can see it. Alright, so if I use my addition formula here for cosine, this means that this is the cosine of 60 times the cosine of 30, do the opposite, minus the sine of 60 times the sine of 30. Alright, so the cosine of 60 is 1/2, cosine of 30 is the square root of 3 over 2, minus the sine of 60 is the square root of 3 over 2. The sine of 30 is 1/2. Notice we get the square root of 3 over 4 minus the square root of 3 over 4, or opposites, and it's 0. So either way you look at that problem, you're getting 0. Alright, I'm going to do one more from this section. And this really looks a little bit different because notice I'm looking at two different angles here. I've got theta, and you know that is usually what we use to denote an angle, but now I'm looking at two angles, so I'm introducing another Greek symbol, but don't freak out about that. That's just representing an angle. This is phi. So if I'm looking for the difference of these two angles, remember my formula says it's the sine of theta times the cosine of phi minus, now I swap them, the sine of phi times the cosine of theta. Alright, so these are the four things I need to know. I need to know the sine of theta, the cosine of phi. I need to know the sine of phi and the cosine of theta. Well, have they given me enough information to find that? Yes, they have, because they told me that the tangent of theta is 4 over 3. So I would drop a triangle, and I would just label it and think, alright, what is this going to look like? Alright, so tangent of theta. Well, there's my theta, and I know that tangent is the opposite over the adjacent, which means my hypotenuse in this case. This is a 3, 4, 5 triangle. So in this case, my hypotenuse is going to be 5. Now, you can certainly picture that this is in quadrant 3 when I drop that triangle. You don't need to worry about that if you're paying attention to the quadrant, because remember that the only values that are positive in quadrant 3 are tangent and cotangent. So my sine and cosine values are going to be negative, because in quadrant 3 I would go to the left, so my x value would be negative, my cosine value would be negative, as is my y value, so my sine value is negative too. All right, but like I said, don't get caught up and worried about that. Just pay attention to your quadrant and use the signs based on the quadrant they give you. All right, so the sine of theta is going to be opposite over hypotenuse, or negative 4 over 5. The cosine of theta is going to be adjacent over hypotenuse, or negative 3 over 5. Those negatives, remember, are coming because quadrant 3. All right, so I've got 2 out of the 4 pieces I need. I'm going to find these other 2 pieces that I need. I'm going to do the same thing, and I'm not going to draw that in quadrant 4. I'm just going to drop another triangle. I don't know why that made that one that big, but I'm going to do the same thing here. There's my phi, and I'm given that the sine is the square root of 10 over 10. It's quadrant 4, that's why it's negative. So I'm doing the opposite over the hypotenuse. And then I'm going to use the Pythagorean Theorem, and I'm not going to work that out for you, but the square root of 10 squared plus the square root of 90 squared is 10 squared. A squared plus B squared equals C squared. All right, so I've found that value that I need. All right, this is in quadrant 4, which means my cosine value is going to be positive. So now I've got the sine of phi equals negative square root of 10 over 10. The cosine of phi is going to be positive adjacent over hypotenuse. So now I've got all 4 of my values, so I'm just plugging it into that difference formula. So I've got the sine of theta. Those weren't supposed to look like negatives. Those were just saying that I've got 4 of my values now. All right, so here we go. We've got the sine of theta, which is negative 4 over 5. The cosine of phi, which is the square root of 90 over 10, minus the sine of phi, which is negative square root of 10 over 10, times the cosine of theta, which is negative 3 over 5. Okay? All right, let's clean this up. And when I multiply that, I get negative 4 times the square root of 90 over 50. Right here, I get a negative times a negative, so that's going to be 3 times the square root of 10 over 50. All right, and you know you can't subtract unless everything is like terms. We have to have like radicals here, and what's underneath the radical has to be the same as well. But if I simplify that, if I look at my perfect square factor that's under the radical, then I see that when I pull that perfect square out, that comes out. So I've got 3 times negative 4, so that's negative 12 times the square root of 10 over 50, minus 3 times the square root of 10 over 50, which is going to be negative 15 square root of 10 over 50. And my last thing, I can certainly divide both of these by 5. And so my final answer is going to be negative 3 times the square root of 10 all over 10.